XML schema. And here's the mapping criteria for that we use to go from X grammar to UML to UML profile for XML schema. I wouldn't go into the detail of this, but the analysis goes like this. Roughly speaking, a non-terminal in the grammar maps to a class in the UML. A terminal maps to an attribute, and so on. But there are some complexities for which you will have to read my thesis, unfortunately. But I'll just leave that here right now, and I'll give you a more visual view of the UML meta model on the next slide, which is right here. So this gives you an idea of the depth and the breadth of the UML meta model, and this also gives a very nice visual representation of the policy grammar that we have developed. It is obviously unreadable at this macro scale, so let's go a little deeper into some of the classes and see the components in a little bit more detail. This is an example of a user credential. As you can see, a user can have a credential type. You also have a permission, which contains an object and an operation. A role definition, which includes a credential type for a role. A credential type can have a credential expression. And there are several other associations of a role, such as constraints and linked roles, which I do not have the time to go into in this talk. Assignment classes include a user assignment object, which can have an optional assignment constraint. And also the permission to role assignment also has permission assignment classes, which can have an assignment constraint. The temporal constraint definition comprises of an interval expression object, a duration expression object, and a periodic time expression object, which can have a start time expression, which defines the periodicity of the event. You can also have separation of duty amongst roles. So this completes the discussion on the policy engineering framework. I will now present a federation architecture that realizes this framework and helps us develop applications using our framework to address requirements of practical systems. So the application that we have used for our framework for the case of my thesis is Federated database schema architecture. And the idea there is that the XGTR-backed policy schema serves as the common data model for the federated system. The multi-level federated database schema architecture is a well-known architecture and comprises of local schema, component schema, export schema, and federation schema. And the idea here is that the common data model for a federated database schema architecture can be utilized for information sharing and exchange in a federated system. And we provide XGTR-backed policy schema as a means to act as a common data model for secure information sharing in federated systems. And since our policy schema aligns with the multi-level federated database schema architecture, therefore it can work with all systems that implement that architecture. Examples of such systems are given on the slide. We have talked about most of the requirements that I earlier outlined, but there's one requirement that we so far haven't talked about, which is federation. So to incorporate federation support, we use the security assertion markup language standard, and we develop a SAML profile. Security assertion markup language is a very well-known federated identity management standard for exchange of security token, and it's backed by industry leaders such as IBM and HP, among others. So we develop a SAML profile where the idea is to have a SAML-compliant format for our attribute-based credentials. The SAML syntax is internally translated into an XGTR-backed credential for internal use by the system. However, the benefit is that the use of SAML results in an interoperable specification. And it allows what's sometimes called single sign-on, that is seamless information access across heterogeneous administrative boundaries. And this is the architecture shown on the slide that we use. Note the decoupling between the authentication and the authorization module, so that the SAML token need not be provided by the authorization module, but can be accepted by the authorization module and generated by a separate authentication module. Here's the system architecture we use to implement our policy framework. I have a federation protocol on the next slide, but I'll probably discuss it over here. The numbered arrows represent the steps in the protocol. The user submits an access request, which could be a SAML request, and the access control module is able to process that request, convert it into an XGTR by credential. It will then look into the policy database for the authorizations for the end user, which will also involve context evaluation. Subject to the evaluation of the constraints on user to role assignment and permission to role assignment, if the request is satisfied, then the access control module will contact the XML data source where the requested information is located. Once the information is located, it is then presented to the instance generator, because going back to the requirement of the propagation option in XML documents, the user may not have access to the entire documents but only to the sub parts of it. And the XML instance generator accordingly generates a pruned view of the document for the requesting user depending on their privileges. And subsequently, the document is returned for presentation to the requesting user. The session management module during this time keeps track of the state of the system, including the user to role assignments and permission to role assignments, and also enforcement of temporal constraints. So this is the Federation protocol, which in many ways is my favorite part of this work, because it brings together everything that we have discussed so far in very nice little steps, 6 or 7 little steps. And this can actually be translated. This represents kind of a pseudocode which can be translated into which can be programmed using a language to in the same series of steps to actually implement the access control policy. So we say that we have a federation protocol and an architecture, and we have tried to address a very important area in federated access management. However, this is not the end of all the problems, and nothing. It's not nearly as close to a perfect solution as we would like. We would have to integrate our solution with cryptographic mechanisms to ensure that nothing is lost on the wire. We would have to perform rigorous testing and validation of the policy framework to see if everything goes as planned and so on, which is all part of our ongoing and future work. So lastly, we will talk about an application of this framework in a healthcare federation scenario. Because of our emphasis on software engineering methodology, we have used use case requirements for a well-known clinical document architecture standard for XML-based electronic health records. And this case study is aimed at secure access of electronic health records. As some of you would know, that electronic health records is a mainstream initiative of the federal government, and there is a regulation that all medical data in medical institutions across the United States must be transformed into an electronic form. In other words, electronic health records will become mandatory within the next decade or so. So clinical document architecture is a most widely used standard for XML-based representation of electronic health records. So the actors in this use case are creators and readers of EHRs, electronic health records that is, the patients associated with the records, the payers, and the institutions, especially the enforcers of legislation such as HIPAA, which is a very strong regulatory requirement to provide security and privacy for electronic health records. So we have a variety of use cases. We have about 5 or 6 different use cases which will be reported in my thesis eventually, but for the lack of time I will discuss only 2 use cases here. Use case number 1 is that access policy for an EHR must have granularity at the level of the medical and administrative portions of the document. So going back to the propagation option, that XML document is hierarchical, it has multiple components, and not everyone can have equal privileges to access all components. Secondly, the granularity should be at the level of the category of the record, and thirdly, on the type of requester within the diverse actor population. Use case number 2 is that the portion of EHR retrieved by a permitted requester depends upon the requester and the disclosure rules defined on the EHR.